Click the bell icon to get latest videos from Ekeeda.
Hello friends, let's discuss problem number 12 today. Let's read the problem first. In this problem we have already given some allocation by a shipping clerk. The following table shows all the necessary information on the availability of supply to each warehouse, the requirement of each market and the unit transportation cost in rupees from each warehouse to each market is given in the table. And the shipping clerk has worked out the following schedule from experience: 12 units from A to Q, 1 unit from A to R, 9 units from A to S, 15 units from B to R, 7 units from C to P, and 1 unit from C to R. Check and see if the clerk has the optimal schedule and find the optimal schedule and minimum transportation cost. So in this problem we are already given the initial solution that has been obtained, or the initial transportation schedule which has been obtained by the shipping clerk, and we are asked whether that solution by the shipping clerk is optimal or not. So here we don't need to do the WAM method. We can easily jump to the Modi method and try to check the optimality of the solution. Let's start the problem. I'll draw the lines first. So we'll just note down the problem. Before noting down the problem, let's check whether the problem is balanced or not. So we have 7 plus 12 plus 17 plus 9. 7 plus 12 is 19. 19 plus 17 is 36, and 9 we have 45. And our supply is 22 plus 15 plus 8. That comes to again 45. So my problem is balance. So you can just note down the problem now. So here I have the warehouses A, B and C, and here are my markets P, Q, R and S. Here is my supply, here is my demand. So I'll just note down the whole problem as it is. 6, 5, 5, 3, 9, 7, 5, 2, 8, 4, 7, 6. Here is my supply 22, 15 and 8. Here is my demand 7, 12, 17 and 9. And here is my total 45. So as we read in the problem, friends, we are already given a transportation schedule by the shipping clerk. Let's try to put down this schedule in the table. So shipping clerk has worked out the following schedule from experience: 12 units from A to Q. So from A to Q there are 12 units. Then he has got 1 unit from A to R. A to R is 1 unit. And 9 units from A to S. A to S we have 9 units. Then we have 15 units from B to R. B to R we have 15 units. 7 units from C to P. C to P we have 7 units. And last we have 1 unit from C to R. C to R we have 1 unit. So we are already done with the allocation given by the shipping clerk: 12, 13 and 9, 22, 15, 7 plus 1 is 8. Column wise it is 7, 12, 15, 16, 11, 17 and 9. So we have got the initial solution, and the problem asks us to find out the optimal solution and check whether the transportation schedule given by the shipping clerk is optimal or not. Let's try to solve it by Modi method. So I'll just give the heading Modi method. Here we have U, here we have V. We'll introduce a 0 in the first row as our tradition, as our conventional method, and then in the first row we have got two occupied cells, 4 minus 0, I will get a 4 here. I got one more occupied cell, 3 minus 0, 3. Then in this particular column I don't have any occupied cell. That means there can be a degeneracy. Let's check the number of occupied cells. 1, 2, 3, 4, 5, 6. So my number of occupied cells are 6. My number of rows plus columns minus 1. My number of rows are 3. Number of columns are 4. Minus 1, 6. That means the solution is not degenerate. Therefore, the solution is not degenerate. So let's check once again the values of U and V. We have got a 0 here. In my first row, I have got 3 occupied cells. 3 minus 0 is 3. I got one more occupied cell here. 5 minus 0, it will be 5. And 4 minus 0 will be 4. Then we have 2 more occupied cells in this third column. We have 2 more occupied cells in the third column. 2 minus 5 minus 3. 8 minus 5 3. Then in this particular last row I have got one more occupied cell here. 5 minus 3, it will come to 2. With this I have done with all the U and the V values, and now we are supposed to calculate the delta values for unoccupied cell. To get the optimality test, we need to calculate the delta values of unoccupied cells. Let's do it on my next page. Delta values of unoccupied cells. We have first unoccupied cell AP, cost is 6 minus 0 plus 2. So at AP, 6 minus 0 plus 2. Next cell we have unoccupied is BP, where the cost is 5 minus 3 plus 2. 5 minus 3 plus 2. Next we have BQ, cost is 9 minus 3 plus 3. So BQ, cost is 9 minus 3 plus 3. Next cell we have unoccupied is BS, cost is 7. So we have cost 7 at BS, unoccupied cell cost is 7. 7 minus 3 plus 4. So BS, 7 minus 3 plus 4. Next unoccupied cell we have CQ, cost is 7 minus 3 plus 3. CQ, 7 minus 3 plus 3. My next unoccupied cell is CS, cost is 6 minus 3 plus 4. CS, cost is 6 minus 3 plus 4. So we have got 1, 2, 3, 4, 5, 6 unoccupied cells. We have got the delta values for all the unoccupied cells. First value will be 6 minus 2. Second will be 5 minus minus 1, 6. Third will be 9 minus 0, 9. Fourth will be 7 minus 1, 6. Fifth will be 7 minus 6, 1. And last will be 6 minus 7 minus 1. So let's note down these values in our table. 4, 6, 9. 4, 6, 9. 6, 1 minus 1. 6, 1 minus 1. So we can see we have got one delta value which is negative. Since the delta value, one of the delta value is negative, we can conclude that this is not the optimal solution. So what we are supposed to do now? We are supposed to make a loop and improve the solution. The loop will start from the highest negative. Since we have already only one negative right now, so I will put a mark here as we will start the loop from this point. Now to make the loop, you can change the directions only at occupied cell. So I am going from here to occupied cell 9, then 1, then again back to 1 and back to the pavilion. So we started from here, so I will put a plus here. Then I went to 9, I will put a minus here. Then I went to 1, I will put a plus here, and I came back to this one, I will again put a minus here. Now if you look at the signs, at the negative sign my allocation is 9, at the negative cell my allocation is 1. So 9 or 1, whichever is less, 9 or 1, whichever is less shall be subtracted. So I will subtract a 1 from here, I will subtract 9 minus 1, I will write 8 here. And whatever has been subtracted from this two particular cell will be added at this two particular cell. Here it will become 1 plus 1, 2. And since this was unoccupied, now it will become occupied and this will become 1. So we have obtained a solution. But again there is a question mark whether this is the optimal or not. Because the problem has asked us to get the minimum transportation cost, that is the optimum cost. So let's again draw the diagram and check whether this table or whether this solution that has been improved is optimal or not. Let's draw the new diagram. So here is my new table. So here I will copy the same table again with the improved solution. So we have P, Q, R, S, we have A, B and C. Here is my demand, here is my supply. So from the table I will just note down the cost first. 6, 3, 5 and 4. 6, 3, 5 and 4. 5, 9, 2 and 7. 5, 9, 2 and 7. 5, 7, 8 and 6. 5, 7, 8 and 6. 22, 15 and 8 my supply. And our demand was 7, 12, 17 and 9. 7, 12, 17 and 9. And now the allocations which were 12, now this becomes 2 and 8. 12, 2 and 8. Then we have 15 in the second row. Then we have 7 and 1 in the last row. So this is my second table under Modi method, where I am trying to check whether the solution that I had obtained by optimizing by using the Modi method in the first step, whether it is optimal or not. Again, we are supposed to calculate the new values of u and v. So I'll put a 0 here. Conventionally, we put a 0 in the first row. And now, in the first row, there are 3 occupied cells. So cost minus u plus v. Cost minus u will get us v and cost minus v will get us u. So 3 minus 0, 5 minus 0 and 4 minus 0. So by using this first 0, I calculated the u and the v values for 3 occupied cells. In the third column, I have got one more occupied cell where the cost is 2. So cost minus v will get me u. So 2 minus 5 minus 3. And in the last column, I have got occupied cell where the cost is 6 minus 4. So we have got all the values of u and v. Just check out once again. We are left with this one particular value. To get this value, I need to check the occupied cell in this column. It is 5. So 5 minus 2, I will get 3 here. So with this, I have got all the u and the v values. Now we need to calculate again the delta values for unoccupied cells. Let's see how to calculate the delta values. We have got a formula for that. Delta values for unoccupied cells. Your formula delta is equal to cost minus u plus v. So in the first unoccupied cell we have is AP. Where the cost is 6. 6 minus 0 plus 3. So 6 minus 0 plus 3, which comes to 3. My next unoccupied cell is BP, where the cost is 5 minus 3 plus 3. So at BP, cost is 5 minus 3 plus 3, which comes to 5. Next we have BQ, where the cost is 9. So 9 minus 3 plus 3. For BQ, cost is 9 minus 3 plus 3, again a 9. At BS, cost is 7. 7 minus 3 plus 4. So at BS, cost is 7. 7 minus 3 plus 4, which comes to 6. Then we have CQ, cost is 7. 7 minus 2 plus 3. So at CQ we have cost 7 minus 2 plus 3, which comes to 2. And last we have CR, where the cost is 8. 8 minus 2 plus 5. 8 minus 2 plus 5, which comes to 1. So friends, we can see we have obtained the delta values. Let's note down these delta values in the original table. We have got 3, 5 and 9. So here is my 3, 5 and 9. Then we have got 6, 2 and 1. 6, 2 and 1. We can observe from the table that all the delta values are positive. None of the delta value is negative. So we can conclude that this is the optimal solution. You just note down this point. Since delta values of unoccupied cells are not negative, solution is optimal. Now what's the final solution? Let's get the final solution in my next table. Optimal cost of transportation So how much we are transporting from where to where? We are transporting from A to Q 12 units at 3 rupees per unit. So A to Q 12 units and cost will be 12 into 3, 36. Then A to R 2 units, cost is 5. A to R 3 units, 2 units, 2 into 5 it will be 10. A to S 8 units, cost is 4. So 8 into 4 it will be 32. B to R 15 units at 2. So B to R 15 units at 2 rupees per unit. Then we have C to P 7 units at 5 rupees. C to P 7 units at 5 rupees. And last we have C to S 1 unit at 6 rupees. C to S 1 unit at 6 rupees. With this, my total cost comes to 36, 46, 48, 78, 108, 108, 138, 143 plus 6, 149 rupees. So this is another way of presenting the final answer. This is a lengthy way. This can be called as my total cost of transportation. That's it, friends. Thanks for watching this video. Do subscribe to our channel Ekeeda.